Hi, my name is Brandon Gracely. I'm a high school math teacher. We're going to look today at rational exponents, or we might call them fractional exponents. When we have a power which has an exponent that is a fraction. So let's look first of all at the integer or whole number exponents. Maybe I have something like 5 cubed, and I'm going to multiply that by 5 to the power 4, 5 to the exponent 4. Our law tells us that we can add those exponents because they have the same base of 5, and together that gives us 5 to the 7. There are 3 5s here and 4 5s there. That's 7 5s altogether. Well, what if we have a power who doesn't have a nice integer exponent like that? So what does it mean to write 5 to the 1/2? Because up here, 5 to the 3, well, that's 3 5s all multiplied together. This is like half of a 5 multiplied together. Or really, it's a 5 multiplied half of a time. That's a little strange. Well, to see what this means, we're going to do a little trick. We're going to multiply 5 to the half times 5 to the half. And that's going to give us 5 to the half plus 1/2. That's using the same rule that we use up here. And that's 5 to the power of 1, or just 5. So this number here, 5 to the half, when we multiply it by itself, or when we square it, we get 5. That is 5 halves. When we square it, we get 5. That means it is the square root of 5. And I'm putting a little 2 there to remind you that's the square root, because there are other kinds of roots. The square root of 5 is 5 to the power of 1/2. Another way to see this is 5 to the half. If I square that, multiplying the exponents, I get 5 to the 1. So that is the same as saying root 5 squared equals 5, which we know. So in general, we have this idea. If you have some base b and you raise it to the power 1 over n, that is equal to the nth root of b. Now this number could be something different. It could be like a 7 or something. Like let's say, I don't know, let's do 32 to the 1/5 is equal to the 5th root of 32. That is, what number multiplied by itself 5 times gives us 32. And in that case, that number is 2. 2 to the power of 5 is 32. So 32 to the 1/5 is 2. That's the way to go backwards. So that's the 5th root of 32. So there's our general form. Whenever you have a 1 over some number, some whole number, for the exponent. Well, what happens if that number is not 1 over something, but it's maybe 5 to the 2/3? Well, our exponent laws tell us that I can change this. I can break this apart using the sort of the opposite of the power rule. Let me just show you off to the side here. The fraction 2/3 can be rewritten as 2 times 1/3. It's 2/3. So I could rewrite this thing here as 5 to the power of 2 times 1/3. Sorry, that's a little hard to read. That says 1/3. But my rule for powers of powers says that I can rewrite this as 5 to the 3rd squared, multiplying, or in this case dividing or factoring out the exponent. Or I could also write this as 5 squared to the 1/3. Now what that means is this second one that I just wrote is the 3rd root of 5 squared, or the one above it I could rewrite it instead like this, the 3rd root of 5 all squared. And they're all the same. Everything here is equivalent. So whenever you have a fraction with a numerator that's not 1, you can take the fraction with the same denominator, but with a numerator 1, and then take that numerator and move it to the outside, or if you want, leave that part here and take the denominator outside. So a fractional exponent that doesn't have a 1 on top isn't really a whole lot harder than a fractional exponent that does. You can just break it apart into 2 pieces. So in general, if you have b to the m over n, that's the bottom number becomes the root part. The top number is the regular exponent, or you can write this as the nth root of b all to the m. Now let's combine these facts here into solving or simplifying some expressions. We'll keep using 5 today, I suppose. 5 to the third times 5 to the 3/7, and maybe we'll raise that to the third power again. Okay, so we'll do the regular order here. Let's look after our exponents first, this power of a power. So I'll rewrite my 5 to the third. And then this here, 3 times 3 is 9, 5 to the 9/7. And now these are two things multiplied together, so I can add their exponents. That's 5 to the third plus 9/7, so that's the whole, maybe I'll put it in brackets here. That's the exponent. Common denominator of 21, so 5 to the something over 21. In this case, it'll be 7 plus 3 times 9 is 27. That's 5 to the 34 over 21. Sorry about that. Okay, so that's all it is. It's a nice fraction like this. If we want to rewrite this as a root, it's the 21st root of 5 to the 34, or it's the 21st root of 5, and that is all to the power 34. So that's how you deal with rational exponents.